Hi friends, in this video we are going to see about what is runtime polymorphism. Okay, so far we have seen static polymorphism, but in this case how we are going to see runtime polymorphism. What is that? How it will help us in our automation and all. Let me try to learn from here. Okay, in the previous example and all, I have created bike b equal to new bike example. Did you remember? Okay, so this way it is the static polymorphism. Okay, directly you are creating a class reference variable and class object, and you are doing this is static polymorphism, which method is going to call. Okay, which method is going to call, like b dot run method will be there. This will be identified at compile time. Okay, this will be identified at compile time. This is static polymorphism or static binding also we can call. Okay, static polymorphism or static binding. Okay, so this method, which method is going to call here? The bike class method, it is going to make a call. It is very simple here. Okay, so this is nothing but when it is going to identify which method to call at compile time. Okay, but my scenario is different. I am going to write one program now, carefully understand. So I want the dynamic feature of that. Okay, I need the dynamic feature of that. So this is the static polymorphism, which we have written same method a number of times, and we are creating the object for that class, and we are making a call to those methods. These all methods are calling and all identifying in the static way. Okay, this is static polymorphism or static binding. Or static binding we can call. But sometimes we need dynamic binding also. Let me create another example. Okay, fine. Okay, this is the class I am having. Okay, very well. But before that, I want to create one class called vehicle class. Okay, vehicle class I am going to have, and I am writing here void one method. I am writing run method. By default, it will run. It runs 80 km per speed, 80 km per hour speed. Okay, this is my method in the vehicle. Now again, I am going to see different vehicles with me, like class. So I can take Maruti is my class, but I am extending this with vehicle class. Okay, and here also I will be having one run method. This car runs with, it runs 100 km per hour speed. Okay, similarly I have one more class as well, bench. This also extends vehicle. Here also I am having one method, run method. It runs 150 km per hour speed. Okay, these three classes I have created. Carefully understand here. So if I want to make a call to all these three methods, then how we can call normally? We can call first Maruti is extending. Maruti m equal to new Maruti I can create. And then I can make a call to m dot run method. Similarly, I can create a bench b equal to new bench I can create. Here also I can make a call to run method. Okay, This way I need to do now. This is nothing but compile time. These two statements going to identify at the compile time only, which method to call and all. Okay, but sometimes I need to decide dynamically. Okay, sometimes I need to decide dynamically which method to run. In that case, we require dynamic polymorphism. That how we are going to implement is very simple. See here, dynamic polymorphism. The syntax is parent class reference. Okay, parent class reference will be there equal to child class object will be there. Okay, please understand clearly. Parent class reference will be there assigned to child class object. With this syntax, it will decide, compiler cannot identify this, which method to run will be decided in runtime. Okay, in runtime. So this is nothing but runtime polymorphism. Which method to invoke, which method to run will be decided in runtime. So parent class reference equal to child class object. Carefully understand here. Let me create one more method. Sorry, one more class. Toyota is there. Okay, Toyota class extends. Let me assume it is having the Maruti 100 I have given. Let me assume here 120 km per speed. But per now I am commenting this. Fine. Now I am going to make a call Toyota also. If I want to make a call Toyota, then I need to again create object to the Toyota also. Toyota t equal to new Toyota t dot, which method is the run method. Okay, like this way, three reference variables you are creating are assigned to the three different objects. These all will be decided at compile time, but I want to decide which method to run in runtime. Okay, now I want to decide which method to run in runtime. Then you need to, as I told you, here syntax should be parent class reference assigned to child class object. Like how you can assign here? What is my parent class? Vehicle. So like this way, let me comment all these, or how I can give vehicle v equal to, okay, so you can give new Maruti this way. So this is your parent class reference variable assigned to child class object. So in this vehicle class, okay, in the Maruti class, what method to run and all, what are all you are running will be decided at runtime. Okay, will be decided at runtime. So now m.run you can give here. So this assigning part, like parent class reference variable to child class object, it means this statement evaluation will happen at runtime, not compile time. Okay, so now I am going to go v.run here. Similar way. Okay, so just I am creating reference variable v, and I am assigning wherever it is required to all these places. So I am giving here also v. Okay, here also v.run will be there. See how simple it is. So here also I am assigning to v and run from v. So v.run. That's it. Like this how we can work. Okay, like this how we can work with this. Yeah, so we are assigning it to what here? So reference variable of vehicle is our superclass, reference variable of the v, and you are assigning the object of child class object. So which object you are assigning, this statement will not be evaluated at compile time. This will be evaluated at runtime. Okay, so you want to invoke which method and all in runtime, not at the compile time. Or in runtime you want to decide which method to invoke and all, then this is the syntax we need to give. So parent class reference variable equal to child class object. Okay, like this way we can assign and we can make a call to those all methods. Now run it and carefully see here. Toyota, I comment this statement. Now which one it is going to run? Anyway, it is inheriting from the vehicle. Vehicle by default, this one is there. It is going to print this statement for the Toyota. See, carefully understand here whether it is printing or not. See, 100, 100, 150 and 80. This 80 is coming from where? 80 is coming from parent vehicle, because in child class we don't have a run method. So since it is in inheritance, is a relationship, it is taking that value from this run method. Okay. So in runtime, you want to decide which method to run and then you need to go with runtime polymorphism. Whereas in runtime polymorphism, how it will be? Parent class reference variable will be there. You are going to assign the child class reference variable. Okay. By using this child class object, okay, you are assigning it to parent class reference. In runtime, it will be decided how it is going to, which method to invoke and all will be decided at runtime. Okay. So even in Selenium also, we are having this statement. Okay. So web driver equal to new Chrome driver, new Firefox driver, new IE driver. All these are based on this runtime polymorphism only. That we will discuss in next video. Okay. So coming to let me brief you on this. So whenever you want to invoke which method and which object and all in runtime, not at compile time, then you need to go with runtime polymorphism. So you are giving the reference variable of the parent class and object of the child class. So in runtime, it will decide which object need to create and which methods need to run. Okay, that is the overview of a runtime polymorphism. Okay, thank you so much, guys. That's all for this video.